Hello, everyone, and welcome to one of a very unique and a wonderful episode in Physio TV. I am Dr. Apurva Shimpi. I am principal of Sancheti College of Physiotherapy, and we always, as physios, talk a lot on the domain of research. We had a wonderful session last time when we talked of the factor of innovation and how innovation can be something very unique or very useful in physiotherapy. To understand the process better, we felt that we can have an expert, somebody who has actually worked in this field in a wonderful way and who can guide us to understand the concept very nicely. Today, we have with us Professor Vaibhav Kulkarni, sir. Sir has more than 20 years of teaching experience and he is a mechanical engineer. He works a lot on product design, in patents and in innovations and startups. Sir is currently working with WIT College at Solapur and he's also member of the National Vernacular Task Force of India. Sir has been very unique in establishing a lot of business, startup units and academia collaboration, including SIR program. And we are very privileged to tell you that he has 4 patents on his name, 4 patents published on his name. Sir is not just an academician, he is a huge researcher and a person of poise and value. He is member of the Atal Academy as a resource person on design training. He is a AICTE recognized translator. Sir is also mentor in charge for Atal Innovation Program. He has been trained by IIM Lucknow in innovation ecosystem, and he is also a very innovative factor. He is an Ministry of Health and Resource Development nominated innovation ambassador with advanced certification. He is a very interesting personality and has authored a book called as titled as Engineering Metallurgy. Sir has trained students on problem-based designs. He has worked on networking on incubation centers across the country, and I think I can go on and on and on a lot about this unique personality. But let us hear from him as to how we as physiotherapists can be involved in getting the work of innovation, maybe patenting it, production or so, and let's hear it from his experience. So we welcome you, Dr. Vaibhav Kulkarni, and I hand over the session to you.
Thank you, Dr. Apurva, for this introduction. Now we will start with the journey. The journey started almost 4 or 5 years back when the biomedical research part of it came into picture. Previously also, we are doing some of the projects which are more towards the mechanical orientation, maybe fabrication type of a projects, and having some sort of a problem to solve. But after the introduction with Dr. Sandeep Bhagwat, who is again a mentor, a guide and friend to me, we started to work on some of the problems which are unique in that field, and we tried to attempt it in a mechanical experiences and the knowledge that we are having. So a collaboration and a co-creation journey started almost 5 years back, 2017. We started with some product innovations, and likely we are now ended up, and this journey is still ongoing, and we are having 3 patents filed in our names. So he is a partner to me in all these patents, and with his guidance in that domain, we could able to create some of the niche products as well. So I am here to give you some insights and some inferences that I draw through these years of experience, where how the student fraternity, they work on a problem solving. That is what my intention, and with that intention, I would like you people to get engaged in this journey. Let us start. I have made one presentation for this session. I will share that presentation in a minute. Give me. This is the topic name, that is multidisciplinary approaches to innovations in physiotherapy. We work together on some of the niche areas where a physiotherapist and a mechanical engineer, maybe a practicing mechanical engineer you can call, who is into academia, but we are working with some of the projects. And with these collaborations, the innovations with these two ecosystems, one ecosystem of the medical fraternity and one ecosystem of the engineering domain. So these two ecosystems, they starts their dialogue, and with these dialogues, we could able to come out with some of the projects, and these are patentable type of a products. These are essentially useful for the society 5.0. In our terminologies and in our domains, we are having a very unique keyword called as Industry 4.0. And this Industry 4.0 is based on the artificial intelligence, the data analysis, then the domains like blockchain, and the newer approaches that are being taken like artificial intelligence and then AR, VR enabled services. So all these are dominating the society. Whether this Industry 4.0 is ready and whether the society which is going to adopt these approaches, whether that society is ready. With that intention, I have just coined this presentation, Innovation with Ecosystem Dialogue for Society 5.0. As Dr. Apurva has already introduced, so I will divide my presentation in these three sectors. The first one is the process of innovation development, how it starts, how that idea could be able to culminate into some sort of a real life product which can be used by the users. Then comes the need to collaborate and co-create. Why the medical practitioners, the physiotherapists, medical scholars, medical science students, why this collaboration is needed? Means as we engineers, we are not having any idea about the human anatomy. You at your part, you know it better than us. And then this collaboration can have some of the innovative products and innovations in that domain. Probably these patents and patents commercialization also, I am going to cover in the need to collaborate and co-create part. Then the final, the summary, we will put it into the ecosystem dialogue. Why it is necessary that one ecosystem should speak with the another ecosystem, so that there could be a dialogue established between these two, and then that dialogue can lead to some of the innovations in that particular domain. That is what the intention of this talk. Hopefully, you will enjoy this journey of innovation. Let us start with the first section, that is the process of innovation and how interesting it is. In engineering institutes, just I will put statistics before you. 94% of the projects which we make in our day-to-day years-long academic journey, that 94% projects, they remain in the institute. Only 6%, they finds the market. And these fortunate 6% which projects are, they are more towards the real life examples. That means whatever the projects that we are doing, they are academic orientations and not to the product orientation. And that's why this evolution of innovation, it starts with something called as a discovery. A discovery of a thought which is in your mind, and this is a very complex scenario that there are many thoughts in your mind. So we need to sync and simplify these thoughts and get them in a proper sequence so that we could lead to have some sort of a publication or invention. That invention, if it is on a paper side, then it will remain in the publication journals. But it needs to come out from the publication part. That research paper needs to come out. You may have some H indexes and you may have many citations in the scholarly citations journals. But still, these inventions need to come out from these papers and need to go to the masses so that that innovation can reach out to the masses. With that intention, we started all these stuffs. In my perception, I treat innovation as innovation is equal to M plus E multiplied by C raised to X, where X is something a radical and C is the relevant context It may be a context, it may be a situation, it may be a scenario, it may be some condition, it may be some situation, it may be some instance at which you generate that idea, and with that instance, it starts to have that coining of something called as innovative idea. Here, M stands for your own mind, my mind. E stands for the emotions of the user and the people or any human being who is going through that situation, going through that context. It may be an accident, it may be some context, it may be a situation, it may be a scene, scenario. We never know that where that idea will stuck to your mind. And this is how the innovation will happen. This is just a generalized formula for the innovation. I'm going to cover that. What do you mean by an idea? Then what do you mean by the POC, that is proof of a concept? How prototyping is done, how we are going to get an idea about whether that part is feasible or not, that is the prototyping. Then how we are going to develop a pilot for that, then how we are going to make a minimal viable product out of it, which is ready for the rollout, and then the final product. So this journey, I will try to take you along with these innovative products. So idea is something which strucks to your mind, that things you wish that it is existed, but can't find. That you wish that this technology should be there, that something I could able to do with this type of a innovativeness, but that is not available. And then that could be a gap that you can identify, that this is the gap where I can pitch in. Need of people around you. So you observe the people, you get their pain points, and then applying your design thinking, you could know that the user persona is having these problems at their disposal, and you could able to rectify these problems. Or else you see that existing product or services, they have these lacunas, or they may be add on with these types of features. So some sort of a feature that you want to go ahead with existing product, that also could be a part where innovation can play their role. Again, you need to have better access to information or products. So maybe the user manual which comes along with the product and how to handle that product, that you want to improve. The app-based technologies where you want to give the user experience a different type of a experience where he will be involved in that journey of a product development. These all are the possibilities where we are going to find the ideas. The very next is how you are going to document them. Documenting them on a paper is called as a proof of your concept. This proof of your concept must be analyzed in some of the fashions. So here is just a graph which I want to put before you. That proof of concept is just a hunch or an idea. It's a mindset where we want to put it in some practical constraint, where it is judged on some of the criteria, like whether that product is desirable, whether that product is feasible, whether that product is viable. That means whether need is there for that product. Second one, whether engineering change management, or from the engineering perspective, can we make that? Can we manufacture that? And if at all, if we could able to manufacture that, in what time limit we are going to manufacture that? Okay, that is the feasibility part of it. And viability means after developing all these, after taking these painstaking effort, whether you are going to get some sort of a commercial benefit out of it. That is something which we are calling the third criteria is viability. So otherwise it will remain as a hunch or an idea which is not attempted. That need to be attempted with the proof of concept. So it is the first document which you prepare like a sketch, like put down all your ideas in a sequential manner. That is the proof of your concept. So somehow you need to articulate that idea and put it on paper so that you can generate a proof of concept of your idea. Okay, fine. Once the proof of idea is there, then the major part which takes the total graph in its capacity is prototyping. So prototyping is very essential, because unless and until we are having some sort of a tangible product in our hand, so that we can feel it, we can sense it, that prototype needs to generate out of this, and it to be tested on the level of its fidelity, its completion and level of fidelity with the user, whether the user is having a satisfactory index on whatever the prototype that you have developed. Okay, once that prototype is with you, then we can go for the pilot testing. Once the pilot testing is implemented, then we can put it to the rollover, that is the minimum viable product, that is ready to go into the market. That is the GTM, go to market strategy. So this is in general a journey of an innovative product, that we starts with an idea. That is the idea where we are calibrating a gap, and that gap which is we are identifying, that identified gap we are putting it into the proof of concept, and then we are making the prototype of it, then converting it into a pilot of it, and then converting it into a minimum viable product which will reach to the market, and it will go through its product life cycle. That means it will be having introduction, then its growth phase, then its saturation point or maturity point, and then it will decline and dispose of from the market. So this is about the life cycle of a product that we want to conceive out of it. Now I will be giving more stress and thrust on the prototype part of it, and with some examples of the medical fraternity, I will try to take you along. So prototype, the proof of concept, prototype, the pilot, and the minimum viable product, how they differentiate it. So proof of concept and prototype are made within the lab, whereas the rollover of a pilot and a minimum viable product would be tested in the real world. And this real world is going to give you the possibility of the product launch. So lab and real world, that matchmaking we need to do somewhere. And this slide is explaining about how a product can start from your mind to market. This is all about that part. You can ask some of the questions, that what is the method is all about, that what you are testing for, when is it used for the process, whether it is an early stage or rollout or live testing type of a stage. What really you are testing, whether you are testing a proof of concept or a hunch or a basic assumption that you have made, a prototype for its idea, or a solution where you want to test it with the user through the pilot testing, or the core of the solution that you want to roll over and go to the market with the solution. So that is called as MVP, minimum viable product. What is the purpose of your testing? When these tests are carried out, what success quantifiable measures that you are going to get, and who will be involved in all these testings. So at proof of concept, the internal stakeholders, that like me and you, who is having some sort of a abstract concept in mind about something as a gap, that is the internal stakeholder. Prototype, we need to test it with the user, maybe the citizens, or maybe the decision makers or sponsors who have assigned these tasks to you. The real users, decision makers, they will be a key role in the testing of your pilot. Then the real users will test your MVP, and that is the go-to-market strategy. Likewise, how much development time will it need? A proof of concept, couple of minutes, naturally a couple of minutes, maybe a few hours or maybe a few days, to put it down sequentially on a paper, that your basic hunch that you want to create into a proof of concept. Then comes the prototype. from half an hour to few days or even some weeks will be needed to produce a tangible product in a lab. Then comes the actual pilot product, where few weeks will be needed, for a couple of months as well, or a year will be needed to test it with the some of the sample sizes that we take to test the pilot. Then it would be MVP. It is a continuous process in the real world. It will be having its development. What costs are involved? In the proof of concept, very less cost will be involved. But as we go on the next and succeeding stages of prototyping and pivoting and piloting, and then go for the MVP, then we are going to get a huge cost which is involved. And that's why it is said that at the prototype stage itself, if you are good enough and having that confidence that you are good to go to the market strategy, then that prototype will be satisfying your need. So fail early, fail fast, fail cheaper is what the mantra for the prototyping. So fail early, fail fast, fail cheaper is what the prototyping is about. And prototype is something, a vehicle of inquiry. That means a user can ask the questions to a tangible product. That product comes as an innovative product in front of them, and they can ask some of the questions, that how it is going to perform this operation, what is the functionality, how that utility, how this feature will work. All these are concerned with the prototype. Hope you are connected and you are getting my points clear for this instance. Now let us come to one interesting equipment that was being developed by IDEO. IDEO is a firm which is a pioneering firm working with the Stanford University, and they are known as a pioneer for design thinking, where they have empathized, defined, ideate, prototype, and test with the users. One incidence, they just observed that there was an ENT specialist who is operating the ear or something, and he is struggling with all these set of wires which are entangled somewhere, and this harness of wire is getting the work efficiency lower and lower. And that's why a need of a product to simplify this wire harness came into picture, and that was given a task to develop to the IDEO team. IDEO team in that way came up with a prototype which was being demonstrated by one of the designer who was attending that meeting with the doctors and medical practitioners, who always having some sort of a indicator about how he is going to hold that particular instrument. So by virtue of that particular gesture or the posture that he wants to make out of it, that particular hand movement he captured, and immediately there itself, using some of the stationary material which was available in the drawer, he could able to come out with something, a prototype like this. A prototype with the particular hand movement he could able to develop like this, that during that early brainstorming which the office supplies, a prototype could be made in such a ugly form. That is early prototype, but essentially that gives an impression to the doctor or the medical practitioner that he said, yes, correct, I want such type of an instrument which need to be operating a particular type of a organ. So that gesture he worked on, and he could able to come up with this type of a prototype. What this prototype is giving all about, this prototype is just giving you an idea about how the product would be. This is ugly prototype, understood, but still it gives an idea that what functionality that you want to establish. Okay. And then a very niche product they developed with very lesser wire harnesses, and this is the IDEO called as gyrus ENT instrument they developed. So the basic idea about their hand movements is culminated into a commercially viable product. This is what the prototype can change your perceptions. And that's why prototype is having that capacity to inquire the user. It is a vehicle of inquiry. You can ask the questions to the prototype, and fail early, fail fast, and fail cheaper would be the mantra for the prototyping. With that, now I will take you to some of the products that we went with the physiotherapist, Dr. Sandeep Bhagwat, and how we could able to develop some of the niche products. One product that we have developed is called as Asan, was sponsored by Autodesk and one of the national winner for the social impact challenge. And this is how the journey of Asan started. We are having a team of our members, students, Siddheshwar Madole, Vishwesh Patil, and Rishikesh Lagli. These were the students, and we too are the mentors for them, myself and Dr. Sandeep Bhagwat. And we started to work on. So student with the challenge, which was being given by the social impact challenge, the students came to me and they discussed this idea that, sir, we want to do this type of a instrument which will relieve the back pain. Okay, we discussed a lot about some of the variables, like we can put it on the shoulder so that the back can be kept upright, and all these types of stuffs we discussed a lot. But somehow at one point of time, I understood that we are missing something, that the part where the human anatomy, which we are dealing as having just an introduction part of it, and not having a good type of a exposure in that field. We were just discussing about whatever comes to our mind, and we are treating all these aspects from the engineering point of view. We then went to Dr. Sandeep Bhagwat, and then altogether Bhagwat sir had changed our perceptions, that instead of a variable, he asked us that it needs to be changed into a seatable. So that seatable part, which we started to work on, is with the basic idea about how the load is distributed. So the load of the torso region is distributed through these ischial tuberosities. And through the ischial tuberosity, we are distributing to the thighs and the rest of the calf muscles and the foot as such. So that part, when it came into picture, then we realized that whatever our thought process, that thought process was not directed in a right direction. He changed our perception, and then we went for the seatable. And the results were incredible. That we are thinking of all these. Let me take the pointer as well so that I can mark something. Yeah, we were working on these types of variables, but after introduction with our mentor, Dr. Sandeep Bhagwat, we changed it into the seatable. The first prototype that which we conceived with the 3D modeling softwares was like this. And then we could able to successively develop it through the user surveys. We put it all the questions to the users who were going through these types of pains. So 84% of the user, they said that we need such type of a product which will relieve us from the back pain. Mention the part where you are experiencing the maximum pain. So this is the part lower back. So L4 and L5 are the vertebrae where these types of pains were more. What type of device would you like to prefer to prevent the back pain? And seatable is having almost 40% of its perception from the user survey. Once it is finalized, then we went for the solution. So this is the solution which we developed called as Asan. And that wicked problem of a back pain, we could able to address to some extent. So this is how the Asan came into picture after changing our perception from a variable to a seatable. So this is a seatable device, almost 3.5 inch in thickness, and having some force accelerometers like this. This is the basic construction of that design. So we are having a seat which is designed for 4 foot 50 mm by 400 mm by 35 mm. And then we installed some of the sensors and microcontrollers, where these 4 sensors with some Arduino Nano type of a microcontroller, that controller is going to judge whatever the loads coming on the ischial tuberosities, and any imbalance, if it happens to that loading at the load distributions, so it will compare that whatever the standard was given for the upright back posture, and what are the changes that are encountered that we have taken, and then we compare them with a program. If at all that goes beyond 10% of the limit, then an alert will come to the user that you are violating the standard norms for the posture. So we made it with the foam, which is again clinically tested, and it is okay for the user. How the working is, it goes with the start button, then it is having the calibration, then goes for checking and giving the alert. This is how sequence of all these events which are going to happen once you put on button, and then the user will go through all these types of sequential events. Then naturally he will turn it off, and that all data goes to an app which we have developed. So that app is for the smart connectivity, and that smart connectivity app will analyze that throughout the day, throughout a week, throughout a month, how many times you violated the standard practices for keeping your back straight. That all collective data would be on a cloud, and that can give the results that if this violation is continued for longer period, then that chronic disease could come into picture called as back pain. Now we are ready with its prototype, and we are approaching some of the manufacturers for our patents technology transfer. So we patented all these stuff, and in the name of the student, and we guided them. We 5 are the stakeholders for that patent, and now we are trying to reach out with some of the manufacturers of these chairs and some of the medical equipment manufacturers, so that we can convert it into a technology transferred type of a product. How that journey is all about, that also I will explain. And this is somehow the news came into picture. Then within the COVID period, we were unstoppable at that event, as our team was working on some of the innovative ideas. So we could able to put on to these thermal glasses. So these are some of the thermal glasses that could able to identify from a mob that here what is the average temperature range, and that thermographs would be in front of us, so that we can identify what is the thermal levels of the mob which we are surrounded by. And it again won a prize in the competitions. This is about the prosthetic leg, which was a concept just we have encountered with applying some of the materials and putting the generative design to this, so that weight of the prosthetic leg would be lesser, and the user can wear this very easily. That is what the intention, and with that we have made this. Then comes the flexion angle limiter for the elbow brace to protect against the self-transmission of COVID. So in the early start of COVID, it was said that in a minute, almost 20 times we are touching our face. So how we can limit that, and that unintentional touch can be avoided. So we made this type of a Pratibandh is what the name of this variable that we have made in a team, and we have attempted some of the competitions as well. So this is the journey which we continued with some of the innovative idea, and then converting into using some modeling techniques, converting and prototyping that with the help of 3D printers. So that is all about the journey. So this is again one cryopod which our students they made. My contribution to this is very lesser, but my students they went along that how with a use of Peltier effect, where we are going to keep the polio vaccine at 4 degrees centigrade. So this is again an innovative product our students they made, and they won the prize at Avishkar, which is the state level innovative product display event, where they won the prize as well. Then recently, in year 2022, that journey continued up to 2021, and up to 21 we are now ready for the technology transfer of Asan, which we made. Now again, as I'm now working with Walchand Institute of Technology, we participated in the Smart India Hackathon, which is a national event for the teams to come out with the innovative products. Our team name was Pain Reliever, and Sandeep Bhagwat sir is again a guide for this. The problem statement was knee support for elderly people to transfer their body weight to the shoes. So with that DST sponsored project, our students they start attempting, and the treatment is like surgery of knee replacement and capping. So it is somewhat very difficult for the elderly people to walk with these types of problems like osteoarthritis. And then the objective that we have put to transfer the concentrated body weight to the ground or shoe, then to relieve the pain at the joints, at the knee joint, to manage any deformities which are likely to come, to compensate the abnormalities in the segment length, and to protect these tissues, to promote the healing, to prevent the excessive range of motion. To your surprise, this is what the students built within 36 hours, continually working with the Fab Lab at Chennai SRM University. They could able to demonstrate these skill sets where they are having the 3D modeling of this, and with the help of our mentor, Dr. Bhagwat sir, we could able to come up with this niche product called as Knee Buddy. And again, all these analysis that we did, this is the prototype that we made. Some of the prototypes that we tested, then we put it for the 3D printing as well. So this is the 3D printing part that students went for. This was the turning point where we are competing with IIT Jammu. So IIT Jammu was our competitor in that domain, and where the students put that our physiotherapist, he instructed us that the body weight is transferred again through the ischium. That part again changed the competition's norms, and then the students could able to work on this product, and all analysis part of how the force is transferred, which are the parts they are safer, which are the parts they come under the loading conditions, how the part and their weight can be reduced. All these stuffs they did on some of the simulation softwares like ANSYS. I will elaborate ANSYS in the next part as well. These are the simulations and the total mass, what is the solid body, how the mass is distributed, what is the volume and density that we are targeting. All these stuffs they calculated. It's the force distribution that matters, and that was validated in the simulation. Once it is validated, they went for the checking of the CAE. CAE is nothing but the computer aided analysis part of it, the engineering part of it, whether it is safer to wear it. That part we analyze. And then the characteristics of knee body is the function, it meets the individual mobility needs and goals. So personalization and customization of that particular product can be done through these characteristics. It produces a comfort for elderly people, and wearing for the long hours also could be easier for them. It meets the individual need for fit in its peers. Then fabrication can be made in the shortest possible time, can be made minimal cost, and the cost for its maintenance as well. It's a simple mechanics which is having the potential to move from a prototype to product. And that is how the knee braces and the load acting combination mechanism could be come together. And that combination is what the knee buddy as a product is all about. Then the students went with the startup as well. They produce the business model which they want to put it to the direct to doctor. Major target customers would be the physiotherapist and the orthopedic physicians who are working day in and day out with these types of patients, where patients are complaining about the knee pain. To attract the doctors, our product, we will have white labeling of the product. So the white labeling will be done for the product, where the doctor on his own clinical practices, he could able to put it to the user. This is how this all is organized, and this is the final product which the student designed, manufactured, prototyped, and displayed at SRM University, Chennai. And within that span of 36 hours, they are the winners at the national levels, won the 1 lakh rupees check for producing this innovative idea. And I can tell you very confidently, unless we went to Dr. Bhagwat, this product wouldn't be in a picture, in a reality. So that's how the two ecosystems which are speaking with one and another should have a dialogue. Then these types of, at night also, late night, the students can make a call to Dr. Bhagwat, and he will again give the assistance to the students. What are the principles that we are practicing in general? So in mechanics, we know that the force distribution, yes, that force distribution we need to manipulate in physiotherapy as well. Then comes the center of gravity and gravity distribution. So how that gravity can be maintained, this is the second principle on which we need to target. The third one is the mechanics of movement, how the axis and planes, they need to work in a proper way so that the movement can be possible. So these are the principles of physiotherapy that again we have implemented it to the product. This is how the product was developed, and we could able to come up with this niche product. The second part of my talk, now it starts. Why the need to collaborate and co-create? Why it is essential? First and foremost, biomedical field and engineering field, which is technologically dominant nowadays, should have a shake hand. Then and then these innovative products could be there in the market. There should be a continuous dialogue with these two ecosystems. That part again could make us for exploring some of the possibilities of collaborative research. We could able to write some of the collaborative research proposals for BIRAC and like DST, Department of Science and Technology, and the Biotechnology Funding Agency. We could able to write them the proposals. Previously, Dr. Bhagwat has attempted this, and with an engineering student, he could able to attempt it for funding of 15 lakhs. We at ASAN, we participated at the National Innovation Contest, and we were amongst the last 18 contestants who won the final round. So we were good in competing at the national level as well. Innovations which are possible in the assistive technologies that can be encashed with this collaboration and co-creation. Somehow the doctors in their practicing journey, they don't go for something called as a product. They take it whatever available in the market and they work it. If at all we need to do the personalization and the customization of some of the products, then product design approach needs to be adopted and tested with the users. There would be a possibility of making the joint patents and publications as well. Commercialization of patents are also possible. Patents can be made and they could be technologically transferred or licensed to some of the major manufacturers in this industry, and you can commercialize your idea and your intellectual property as such. Let us move ahead. A course can be developed. Already it is one of my friend, he has worked with a company called Deso, and they worked on some of the 3D technologies, where a course can be developed for introduction to the doctors and medical practitioners and physiotherapists, introduction to 3D technologies and 3D modeling platforms, sketching of the body parts and implants. Unity is one of the company that we know for gamification, but that company is again making the human organs which are enabled with the anatomy of that organs, and in AR and VR experiences, that is augmented reality, virtual reality, and mixed reality, MR as well, that can be tested. So these are the implants which they make in Unity. 3D solid modeling for the body parts, then surface modeling of body parts, that applying the skin, then whatever the skin and its specialities that we can have. Recently, I came across with a 3D printer, which is printing a type of a skin to those who need type of a wounds or some burning issues. For them, burn parts of body, they are making such type of a 3D printed skins. Assembly design for the body parts, then 3D scanning and their applications. So with 3D scanners of high-end 3D scanners, we could just, if suppose this is a bottle, I would just put the 3D scanner all around and we could able to design that 3D model of with all its specifications. That 3D model can be generated. Post-processing of all these scan data, introduction to 3D printing and rapid prototyping. With the advent of technology like 3D printing and rapid prototyping, prototyping is no longer an issue which takes years together. That is curtailed to a week or a couple of days. So 3D printing, how that can augment to the task of a physiotherapist. Study of biocompatible materials. Then the researchers can put their views on biocompatible materials. The testing part could be taken care by some of the engineers as well. Introduction to finite element analysis, structural analysis with 3D modeling softwares. Now, ANSYS is one of the major software supplying company. They came up with simulation to save the lives. Adding to that, what outcomes that we are targeting? Doctor, physiotherapists, medical science professionals, scholars to become familiar and conversant with the 3D digital technologies. They need to work with the 3D world, 3D scanning part of it, 3D printing, augmented reality and virtual reality and mixed reality type of simulations, where they will get a virtual environment where they can actually put themselves and see that how that part will behave. They will prepare to use the tools and technologies which are becoming essential part of medical science field. And as a patient and healthcare comes into picture, so we need to augment with all these technologies. As I explained, that Deso is having virtual twins for humans, the next horizon for the healthcare, as well as a part called as a digital twin, where actually a living heart can be simulated in a digital environment called as digital twin. This is the budding technologies, and the in the near future, hopefully in a year or 5 years of span, we can have the digital twins established in all the health sector units as well. A digital twin can provide assistance in determining the right therapy option for a specific patient. So that is the personalization and customization of the healthcare product. A digital twin can encompass a patient's imaging records, laboratory results, genetic data, and combined with the model to the prostate cancers or clinical pathways or any such deformities which comes into the body, that also can be taken as a record. So that product life cycle is also could be put into a management issue. That is what engineering can contribute in that way. What you and me can do together, we are having a force of students who are intellectually very strong, and they can contribute in some of the hackathons, which can be organized jointly with the medical fraternity and engineering fraternity. And these joint hackathons can have some of the products as an outcome, can have some of the competitions and events where the students can collaboratively work, and problem statements will be thrown by the regular practitioners and attempted by the engineering students. So such type of hackathons can be possible in the near future. These are some of the available websites from where you can attempt for the competitions. It's said that engineers, they attempt, but all these competitions, they are open for all. Those physiotherapists who are having the innovative mindsets, they can attempt all these hackathons and competitions as well. Dare to compete. Formerly it was Dare to Compete, now it is known as Unstop. This is one website where all these competitions are floated. You can attempt all these competitions and events so that we can polish our knowledge and we can make it a better society. Last part of my talk is the ecosystem dialogue. Within that ecosystem dialogue, these are the technology readiness levels. For engineering, there is technology readiness level, which we call it as up to TRL4, we are calling it as a lab demonstrated product. Once it is TRL5, that is lab scale validation, that is early prototype. As you have seen the knee buddy and Asan is now up to TRL7, but the early prototype is TRL5 of knee buddy, that is tested at the lab and scalable to the demonstration purpose. Then prototype demonstration is TRL6. Capability which are validated on the viable product and runs, economic runs, is TRL7. Then TRL8 and TRL9. TRL9 is the MVP. TRL8 is the pilot. Okay. For a medical science student, here is at the bottom, intentionally I have kept it, that medical science, they will be having a basic research called as TRL1 and TRL2. Preclinical research comes under the category of technology readiness level TRL3 and TRL4. Late preclinical research, phase 1 trials, phase 2 trials, phase 3 trials, and phase 4 trials are go to market, ready to market. So these are the possible technology readiness levels for the medical practitioners that can be demonstrated with these types of timelines. If you see that research will be done at the basic and preclinical research, then the translation into some tangible would happen in the development phase up to half of 6.5 TRL, you can call it. Then the commercialization part starts and it is ready to go to the market. Here is what the sectors for growth that we can put it. The academia, they can put and fill this gap so that this curve would be, this is called as a valley of death, where the real tech development is not happening. And if we could able to concentrate on this gap, then we can have the smooth introduction, then it's a growth phase, and then it will reach to the maturity, and then it will decline and dispose off from the life cycle. This is how we are putting the TRLs on basic research, applied research, technology development, prototype, and it's a system development type of it. Now I'm working with some of the startups who could able to demonstrate these types of TRLs, and they are ready to get some of the funding. Some of them they have already pitched and they got some angel funding as well. What are the challenges in IP commercialization? These are the challenges that day to day we face. Low TRLs. That means there is not a perception that what is the actual TRL that we have attempted. We may say that this is the TRL level 5, but that may be TRL level 3, maybe POC. Lack of funding for scaling up the pilot studies. Market validation and field testing is somewhere limited. Market research and commercial potential assessment is having totally ignored domain. Risk capital, then inadequate IP awareness. So patenting all these stuffs. Now we are going for patenting of knee body for its leaf spring type of a arrangement that we did as a mechanism. So we are going for patenting that part. Then complex irregularities, then inadequate incentives for the inventors and innovators. Higher technology transfer cost. So whenever it transfers, then the negotiation part of it is somewhere missing, where commercialization of that patent, as I am having some belongingness to the product, I will put it more on the technology transfer and licensing part of it. And that's why this is not happening. No national guidelines on IP evaluations. So valuation, how we are going to treat for the IP, that is no guidelines are there. Patents are not technologies. Most of them, they are about the POCs. They are just the proof of your concept. They are not the product or technologies as such. Low patents and commercialization rates are also being taken care. Finally, this is how the patent commercialization framework works. Patent gives you the know-how about how you are going to make it. Preparing the marketing literature and technology covering of the product and the technical commercialization aspects of it needs to be done at our end. Market the technology through print, digital media, and interested parties. Commercialization will happen through these advertising media campaigns. Conduct the due diligence. Due diligence is the keyword in the startups, where all legal or the legalities which are associated with the product should be satisfied. Then it is ready for the licensed. Negotiating on the term sheets. And if the negotiation is successful, then you can have signing of the technology transfer document. That is the know-how document that we need to transfer to the industry. That is a transfer of technology. So this is all about how you can go for the successful operation of that patent into the plant and marketing of that product. Lastly, I just want to put a slide where we people, as you are the Sancheti Academy and the School of Physiotherapy, they are the knowledge builders. So we are the enablers in the knowledge field. So Saraswati is the deity for that. We need to protect our IP, and that's why Durga's part, the Ashtabhuja Durga, will come into picture, so that we can protect our innovation with some of the IP protections, that is patent. In making all these, the Lakshmi will come, the commercialization part of it. Where that can be augmented, where the health sector is in this COVID era, we have gone through such a unprecedented type of a times where we know that health is the most important part. So the augmentation of all these will come later, but first the health will come. And this Dhanvantari will have its collaboration with these sectors of engineering, and hopefully that ecosystem dialogue will happen. And with this, I will come to an end of my talk. in a near future, we will have more dialogues like this. Thank you, Sancheti Academy and Dr. Apur, for giving me this opportunity to share whatever my experiences and the innovative product that we have made so far. This is a journey and it is not the goal. It is still continued on that path. Thank you.
Thank you so much, sir. I mean, this was really, really very insightful because you were speaking from your heart, from your experience and understanding of these domains. And I believe you made it very easy for all of us to understand the topic. I recently had the privilege to hear a talk by Dr. Abhay Jere sir, and he was actually talking on the need of innovation, which is especially for the millennials in this post-COVID era where everything is available online and why there is so much of a need. And one beautiful thing that I really liked what he said was research is when you convert wealth into an idea, whereas innovation is where you convert idea into wealth. And this is something that we as healthcare professionals should also think about how our ideas or innovations can be worked about. Your entire concept, first and foremost, the innovation theory itself was beautiful. The M plus E into C raised to X. I mean, that was a concept itself. And the components that you talked about, asan, thermal gun, prosthetic leg concept, flexion angle limiter. I mean, things, they were simple, but yet beautiful and so useful for everything. So the take home message for all the listeners would be how we can, apply our minds, be open to ideas and criticisms also, because you rightly said failing early and failing faster is also a cheaper.
Need to be appreciated.
Yes.
Need to be appreciated again.
So I have one or two questions. I know we are running on time, but
yes,
just one or two. This, because we are targeting on the students, and generally the concept of them will be how do we know that the project works and whom do we really approach to?
okay, there should be a sample size of users from where your observation skills matters. Means whether the need is there, the desirability is what the factor that we need to concentrate more. If at all that is desirable, then naturally the user will give you some of the feedbacks, and that feedbacks are going to improve the design capabilities of that particular product. And that's how you are means these prototypes, they will be developing continuously, they will be developing. Right. It is not the fact that one size fits for all. It is not like that. So you need to improvise on your designs. That will come with the user persona and interaction with the user. Who is the actual user of that? When you discuss with them their pain points, and then naturally you come to know that these are the lacunas that we need to overcome on. And then we can have that product in a developing stage, and still it will remain in a developing stage. And finally, if that user is satisfied, then we can take a sample size of such type of experiences, those who are having a similar type of experiences, and there we can put this, that is called as a pilot run, where in the real world we are testing it. And once it is validated, then we can go for the GTM part of it. That is the strategy to go to market.
So as you are saying, needs assessment is equally important to understand what we are doing. And last question is, how do I know if my idea is original or it already exists somewhere?
We need to do extensive patent search for that. There are some of the available patent websites. If you allow me, so in the near maybe after half an hour, I can put it to you, so that a ready reckoner can be with the students, so that they can test it for the patentability. Whether that artifact is already existed, someone having that right of its intellectual property, that can be tested on some of the websites. Like IP India Search is for Indian patents, like eSpaceNet is for the European patents. Then we are having WIPO's. WIPO is World Intellectual Property Organization, and their website is also available, where international patent classifications are made. And for clinical research, there is separate segment where these classified parts, we need to work in that sector only. That is the international patent classification for medical devices. That is a separate category we need to adopt. And these patent search are limited. Google patent is also available, but it will give you all type of patents. We need to converge to something with the keywords and advanced search, so that we can direct it towards whatever the intended purpose or the intended idea that we are going to target. Otherwise, for a keyword, we will get almost 50,000 plus product which are available. So we need to converge somewhere where that patentability search needs to be extensively done, so that our idea, whether it is patentable or not, that can be checked. I will give you some of the websites where the students can work on, and they can test their ideas on that.
Sure. So that's really very sweet of you, sir. And thank you so much on behalf of Physio TV. I really appreciate you for spending your valuable time. I realized that we had committed to some, and you really went to a very great extent to explain us a lot of things. We really appreciate you for your time and the inputs. And once again, thank you so much for giving this wonderful topic to us.
Thank you. Thank you,
So
Apurva.
take care, and we'll see you soon. Bye-bye.
Thank you.